Greetings from Mobility Outlook and welcome to Mobility Conversations. Our guest for today is Mr. Rafiq Somani, Area Vice President, India and South Asia Pacific, ANSYS. Rafiq, welcome to the show.
My pleasure.
How are you? How are things?
Yeah, good. First of all, thanks Murli for coming over to our Delhi office. Everything good. We are on the year-end month, so yeah, exciting times. Yeah.
So how was 2023?
Yeah, so this year has been very good. As we were discussing earlier, this will be our 9th year in a row that our region, which is India, ASEAN and ANZ, will be overachieving 100% plus. And,
wow, congratulations.
Yeah, this year is also looking very good so far. We are on the plan, yeah. So pretty exciting. Yeah.
Mm-hmm. Great. Tell us how ANSYS is helping scientists and engineers involved in AI, machine learning, IoT, a lot of things that are being talked about now.
Yeah. So I think, of course, thanks to OpenAI, AI/ML has become a little, fashionable term now. Everybody's talking about it. But ANSYS, as a technology, we were already having, AI and ML technologies. We started very early from our semiconductor solution through Seascape. But currently we have kind of offered three pillars of AI/ML. Of course, the first one is we call it ANSYS Sim AI. Basically, it is a ML platform, and what it does is kind of generative and self-learning mechanism to optimize and make all our technology and applications result for all the engineers and scientists very accurate and very fast. Sometimes we are getting results as per customer from 100x to 1000x faster. So that is the first piece, which is kind of the machine learning platform. The second one is we give credit to Chat GPT. We have used we have tied up with OpenAI, and what we have created is ANSYS GPT. And basically it's a virtual assistant or virtual help to all the engineers and scientists where they can ask any question, which is all ANSYS public data, domain data, engineering data, training data, all the content, even the local language, you can ask a question in Tamil and get a Tamil answer, and it will give you all the possible solution for a problem, including maybe some videos, tutorials, and some training learned to links to our training hub, what we call as ALH and other parts. And the third pillar of ANSYS is what we call as ANSYS AI Plus. Basically, it's an add-on to our core application, which make our technology faster. Okay. So in that sense, ANSYS is providing some world-class AI/ML tools and solutions for our customers.
Have all these things helped you to reduce the training time?
Oh, absolutely. I think what we have observed already for our beta ANSYS Chat GPT is the number of calls and requests coming to our engineers for support has dramatically reduced, because sometimes it is little, the engineers are also thinking, should I call up ANSYS for maybe is my question too basic? Okay. And they kind of 80% of the time they get all the solutions. So it's basically drastically dropped down the time for them also, and now our engineers and support engineers spend more on qualitative support rather than very transactional support, which can be very tactical.
Okay, great.
So it has helped a lot, reduce the time very much, significantly.
Very good. How is ANSYS helping the automotive industry, because which is focusing more on the connected, autonomous, shared and electric?
Yeah. So I think this is a very good question. If you look at today's case, what they call it, connected, autonomous, shared and electric, is as a like a generation of technology for automotive is totally different from what the IC engine used to be. Correct? First of all, the first thing which we look in the case autonomous is like the perception. The car has to see and hear and sense like human beings, and that means a lot of sensors, a lot of cameras, a lot of lidars, a lot of radar, a lot of connected technologies, V2X, V2 human connection. So in that sense, now the case automotive is like you have the supercomputer rather than traditional IC engine. So when we have so much of technologies in a car, a connected car, then that it means safety and reliability becomes very, very important. We can't make an error, correct? And because there is so many millions of lines of software code and a lot of sensors and lidars and cameras and radars, a lot of communication happening, a lot of EMI MC issues, placement issues of these cameras, sensors, lidars, plus the software code, and today it is estimated, if you can, there is a quote from X quote from Toyota president. He had said that a connected car would have to be driven 8.8 billion miles.
Yeah, I saw that.
And now, just imagine it'll take centuries or maybe, 15,000 trips to moon and back. It is impossible to kind of do, testing for 8.8 billion miles. Now, then very clearly simulation plays a very important role over there. So the engineer can, once the software is developed, he can test virtually and run various use cases and scenarios which may not be possible physically also, like a car going through a tunnel from Pune to Mumbai and on expressway, and different conditions are there.
Correct.
Thunderstorm, lighting, rain, sun, breeze, and going through tunnel also. All the scenarios can be predicted, even corner cases which have never happened and which can happen. So virtually once we do that, there is no fear of failure. And so that is one thing. So it tremendously cut down the cycle time for product development and software testing and the vehicle testing. We have some customer who just kind of want their car coming out first time right, and they are just doing physical road testing for compliance and regulatory requirements. So that is one piece, the safety and the billions of lines to be virtually simulated rather than physically simulated. So that is a very, very clear big advantage. The other one is when I talked about safety, security, somebody can hack into your car and create an havoc. Now, the embedded software which is there, which is running millions of lines, it is IS 2626 compliant and AUTOSAR compliant. So we are very much sure that the software output, embedded software is compliant and safe. There are a lot of security software which are again compliant. So that is the second piece. The third piece is, of course, when you have all these electronics, a lot of EMI MC issues can happen, and the placement of all these sensors, cameras, and lidars to optimize and to have the right algorithm software to do the right perception, it becomes very, very important. So I think these three things totally make the case automotive different from IC engine, and of course all the other IC engine applications like the structural, the thermal, the drag and crash test, weight optimization, all those the IC engine technology or application of the core physics of applications will also be applied to case also, because we do crash test to LS Dyna and the drag and fluids flow analysis for for noise, and NVH is becoming very important for all these latest cars. So infotainment is all very important. So in that sense, huge pressure on the engineers because of all these new set of technologies and software going into case automotives. Yeah.
I agree. Simulation plays a very vital role, but it also comes with a set of challenges, like for example, accuracy concerns, compatibility related thing, validation, verification, and also integrating it with the physical testing. In this scenario, how does ANSYS help?
So Murli, it's a good question. So I think first of all, we have to very clearly remember ANSYS is leveraging its 50 years plus experience in the industry. Having said so, we are continuously learning, correct? And if you look at, I just spoke to you about case and how different application software technology is there. So let me explain and elaborate a good question of yours. So ANSYS, has a very structured modular platform of our technologies. So what we have done is at the core base level, all the physics are there. Traditional applications like structural, fluids, electromagnetic, semiconductor, optical. So these core physics are the main pillars, which are each of the technologies a gold standard. So when we are acquiring a new company or developing new technology, it doesn't mean that we are forgetting our core physics technology. So each of them is a gold standard. And the second thing is they are tightly integrated and multiphysics. So today you look at your mobile phone or a car, electric car or traditional IC engine car also. It's a multiphysics situation. It is not just, you cannot just say a car is anymore a mechanical device. It's got a lot of other things, sensor and software and embedded software and fluids and mechanical. And so I think that pillar is there. On top of that, we have what we call as the software and systems. So I spoke to you about all the embedded software, functional safety, technology, software technology is there, which today all the cars and consumer product needed, and they kind of interface with our core physics. So that becomes important. So again, that is tightly integrated to our core physics platform. Then what we have is system of system. So today, what I mean by system of system is mission engineering, or we just saw Chandrayaan-3 launch, correct? So so to the point, like ANSYS technology is so tightly integrated and so sophisticated. So from developing a microchip, a nano chip, to a mission engineering, the entire, not only the rocket launcher and the satellites and the rover and not only that, the entire mission, at the Earth atmosphere and the Moon atmosphere, what we call as mission engineering is the simulation technology. So I think we have a very deep and tight integration. And when I on top of this system of system, we have again like vertically all these technologies leverage the world class, the GPUs, the cloud, HPC technologies. So in that sense, from the foundation physics to embedded software to mission engineering software to the the leveraging HPC cloud and GPUs, our software is very tightly integrated, and each of these technologies is a gold standard. And naturally, then because of this this platform and integration, it gives us a very competitive advantage to work on different technologies, whether it is ADAS, autonomous, electric, 5G, and everything. So I think in that sense, we are a very unique company and unique technology to have these very unique integrated platform. We may have some other colleagues and friends, our peer software, they may have niche technologies, but I don't think so in the marketplace there's any technology which gives all the solution, various application, various physics and it is so tightly integrated.
So there are a lot of complexities in addressing the customer's concern. Many things. Very interesting. Uh, there is also connected technologies coming in a big way. 5G is there. India has become a test lab for 6G.
Yeah.
And there are complexities in electronics and software.
Yeah.
What kind of support ANSYS gives
Yeah.
to the customers?
Yeah, so I think it's a very interesting, technology and movement happening, and I'm very happy that India is pretty much in line with the global standards. Lot of research work is happening in India, including IIT Madras. So basically, first of all, we have to realize that this 5G and 6G is no more just to do with telecommunication, correct? Because now, it'll get involved into healthcare, ADAS and autonomy, which we spoke about. Even mission engineering, correct? Space and all. So the application is so wide and diverse now. Internet of Things, industrial IoT, everything it'll get involved. So the expectation of the consumer is they need speed. You cannot have any drop or any data loss. Again, security and all that becomes very, very important. And I think first of all we have to realize that for this you need about 6G if you're talking 360 gigahertz per. So we are talking of high bandwidth. Also, it means the electronics and components and all the devices becomes very dense. Now that brings a lot of product development challenges for engineers because when we are trying to put in all these technologies together and still have the the no power loss, the batteries inside not blowing up, not heating up, and performing to cutting edge, and they are reliable and safe, puts a lot of pressure on engineers. So basically, when kind of we condense and miniaturize all these technology and increase the bandwidth, that there is a lot of pressure on the system, correct? And that's where ANSYS simulation, again stands out and very supports be it's the matter of all the electronic devices, right placement, avoiding all the EMI/MC issues, heat, power, and multiphysics, because a lot of physics is playing into the play, including reliability, embedded software, which we spoke about. The technologies and software which we develop has to be compliant. So I think we are very happy that ANSYS technology is playing a very, very important role. With all the new technologies in 5G and 6G coming in.
Okay, great. See, some of the market reports say that the simulation market is going to grow by $16 billion. In 4 years, from 2024 to 2028. Astonishing. So, what kind of opportunities you see for ANSYS to grow?
So ANSYS is very, very aggressive on that front. We have it's not just the market data which we are relying, but our own study and the experience and our interaction with the market is telling us that this, as you rightly mentioned, the market is booming and will grow very fast, and there is a lot of upside. So ANSYS has a very clear strategy. We have broken down our growth strategy into 3 segments. So let me explain it a little bit detail, and it's a published data, so I can talk about it. The first is the foundation software, the core technologies, which is like our all the physics, structure, fluids, and electromagnetic and semiconductor. Now, if you look at the core foundation simulation market, it is growing about 8 to 10%. Now, if that market is growing, we are growing faster than our peers. much faster by just not 1 or 2 points, but at least 3-4 points. So that means in the core physics market, foundation market itself, we are having a growth. So that is the first piece. So we have a very clear plan, and as I rightly said, we will continue to invest on all these gold standard multiphysics, core physics platform, which is our bread and butter. We call it cash cow product. We will not lose focus on that. That's itself is a growth market. There are two other markets which are growing faster. Of course, the baseline is smaller, but in the future, in the coming year, it'll grow faster. The second, what we call, is the new and emerging technologies, the second pillar of the growth, where we are talking about this ADAS and autonomy, electrification, 5G, 6G, IoT and industrial internet, correct? So that is the second, and again AI, ML and all these, I would say they pretty much come sit into this. And if you look at our track record for the last 5 years, I think we have acquired more than 16-18 companies in the last 5 years alone. So we are kind of consolidating and getting ready, and we are already seeing traction in that new and emerging technologies. And the third piece and the third pillar of the growth, which we are calling, is the new adjacencies. What I mean is that traditionally, simulation technology or ANSYS was used only in design and simulation field. But today, because of all this multiphysics and the people have started using and see value on using ANSYS through the entire product development life cycle. So what I mean is, from the ideation stage, when you're conceptualizing, even the design engineers, we have a solution called and that is getting a lot of traction. And then you have our flagship products for the simulation. And then of course there is what we call is the manufacturing and operation. So when the product is also getting manufactured, we have Additive, 3D additive manufacturing solution. And when the product goes into operation, then we have our twin builder, digital twin and other technologies. So to answer your question and summarize again, ANSYS will continue to grow in the core foundation market, will continue to grow in the new and emerging technologies, which will grow faster, and then the new adjacencies, which I talked about, number of users, what we call as intensity and density of usage across all these three growth areas will continue to grow tremendously.
Yeah. So we have covered the supply side, the tier 1 companies, the vehicle manufacturers, the product per se, and now there is a big opportunity in the manufacturing per se. You talked about 3D printing, etc. So how does ANSYS help them, the manufacturers, in probably doing more for less?
So first of all, we all understand and appreciate that additive manufacturing has got a huge future, and it is not just it's crossed the hype cycle, and I have seen a lot of industrial application of usage, not just for prototyping. Earlier it used to be called used for prototypes, but I have seen now industrial usage application. So that is a growth market for us. And but when we talk about it, that market has huge challenges. Huge challenges in terms of wastages. What I mean by wastages is, like, you may design a part, but what you manufacture is totally different from what you design. So while you may have designed during the manufacturing 3D additive manufacturing process, and as it get manufactured, the products can get bulge, they can create cracks, and it may print out in a totally different form. So and it's leading to a lot of loss of time of machinery, expensive material, and the part getting wasted. So ANSYS has a technology on additive in such a way that we cover the entire additive manufacturing process. So let me explain you a little bit. Like, Just imagine you are trying to print a air filter. Now air filter, as you are designing, and what you will print will be different. It will bulge out while printing. So what we do in additive manufacturing software in ANSYS is kind of the design, the product, the simulation technology takes care of the bulge which will happen, and it kind of redesign.
That is designed for manufacturing.
Yeah, exactly. Yeah, that is designed for manufacturing, and in that also we have technologies like topology optimization, and it will optimize the design in such a way that you can get drastic weight reduction opportunities without losing the reliability and the strength of the parts. Now once you have done the design for manufacturing, we go into the validation stage where you are actually doing all the core physics analysis validation on the part that will be printed, including structural, all the multiphysics thing. And then there's a process part in the additive manufacturing. So we have technologies which takes care of the process related manufacturing process related matter, including later on the stage, the microstructure of the material. So we may be the only simulation technologies which kind of helps in the microstructure analysis. Again, in additive manufacturing, we have solution through Granta, which gives a material library for different materials for customer into additive manufacturing using our technologies. Yeah, and again, not to say that we are compatible to all kind of metal printing machineries, and we have tie-up with them, so it works out very, very well. Yeah.
A simulation helps in reducing the time to market, development time, etc. How has simulation compressed the time during the last 5 years?
Yeah.
And how is it going to be in the next 5 years?
Yeah, I think it's a good question. I think first of all, fundamentally, we have to remember why people are trying to use ANSYS technology, correct? The very clear idea is you can't launch a mobile phone which will fail in the market, or you can't launch a car where you have to recall it, correct? People are talking of first time right. Now, when you want to have a product which is first time right, that means you have to do a lot of testing after you have done the design, correct? And testing, as we discuss in ADAS technologies, it takes a lot of time. You have to make multiple prototypes. There are chances of making mistake, human errors can happen, and it is very time consuming. So today the ANSYS technology has the fidelity and the accuracy of simulation result is so accurate that the engineers have full confidence on the results which ANSYS will show virtually. So the customers, our end customers, are trying to avoid physical prototype and do multiple iteration and testing virtually. And remember, that is not just one great benefit of reducing the cycle time. Now, if I'm failing virtually and I'm not losing any money, then I will try to innovate also, correct? So I think what I'm trying to say is ANSYS technology just does not reduce the cycle time and avoid the prototyping cost and time to market, but it gives engineers freedom to innovate, because he can do multiple trials, change the material, try to change aesthetic, and check whether it is manufacturable or not. So I think what I want to say is not only it cut down the cycle time dramatically, but it gives opportunity to engineers to innovate also. So I think of cutting down the cycle time and which is getting used, but then we have now spoken about and then with digital twin becoming common, digital twin was supposed to be only used by industrial engineering company, which are very expensive assets where you can't afford a downtime like a nuclear plant or a big industrial pump. But it is predicted, and as the NVIDIA CEO and president has said, that we'll have digital twin for almost every product. So again, that is that's a very clear advantage ANSYS will have. We ourselves, human bodies can have a digital twin like Avatar, and maybe our great grandsons, children can still see and what is happening to our body. Can always be tested by your doctors, and like specialized, customized healthcare rather than mass healthcare will become very common thanks to digital twin.
Great. Rafiq, thank you so much.
Yeah.
Thank you so much for talking to Mobility
Yeah,
Outlook.
it's pleasure. Yeah,
Yeah,
thank you
so
for
much.
coming over, and always pleasure talking to you.
Thank you.
Best wishes
Thanks.
for your rest of the meetings.
Thank you.